And in our final lesson, as I mentioned, we are talking about box plots. We want to know how to understand and interpret a box plot, and we also want to make sure that we understand the relationship between a box plot and a five-number summary. As we talked about it earlier, a box plot, right, largely does display the values of a five-number summary, right? But let's first talk about some nomenclature, right? You'll often hear these called just box plots, but a box and whisker plot is also commonly referred to as a box plot, right? So box and whisker plot is maybe a different name, and we can sort of see that we have a box and we have some whiskers, right? A lower whisker and an upper whisker. But as we talked about when we talked about calculating the five-number summary, the box plot in general is a visual representation of that five-number summary. We can see we have the median, we have Q1, we have the min, we have Q3, we have the max, right? What this does is this divides our data into four quartiles, right? The lowest quartile, the two center quartiles, and then the upper quartile. And it gives us an idea of how our data is distributed, much like a histogram can, right? Although we're sort of stuck with sort of four bins here, right? We just have lower quarter, middle two quarters, upper quarter. But, right, we can see this is really valuable. We didn't talk about it super in depth, but there is this statistic called the IQR, which is the interquartile range, and that is the range between Q1 and Q3. And what that tells us is that the middle 50% of our data in this data set lies in this interquartile range, right? Or in this interval between Q1 and Q3, right? We can also see where that median is, right? Here it looks like we've got actually more data or a larger range for this lower half quartile than we do for the upper half quartile, right? So having this line through the box, right? The box represents our middle 50% of data, right? But this median line, there's 25% of our data on either side of it inside of the box, right? So this lower half, right? But really this second quartile, right, is much more spread out, right, than this sort of third quartile, this upper half quartile. So that's the basics of a box plot. We have another example here. Sometimes when you see these visualized, instead of taking the whisker all the way out to the end, they will only take it out partially. And at the upper bound, we can actually see here, right, there are 2 points. These are statistical outliers, right? And there is a way for calculating a statistical outlier. In general, it is considered 1.5 times the IQR. Right? So whatever this distance is between Q1 and Q3 times 1.5, if the data is beyond Q3 plus 1.5 IQRs, right, it's sort of officially, in quotes there, officially an outlier, and we can represent it a little bit different visually, right? Because what we're saying is, hey, most of our data is really pretty compact here. I just have a couple of outliers that might make it seem a lot more spread out than it actually is. And we can see in this data set, 293, 9487, most of these values are between, say, 2 and 12, right? But we do have 19 and 20, which are outliers, and we can actually see those being visually represented as such in our box plot. Now, we talked about skewness, negative or left skewness, when we were looking at histograms, and we can display that same, we can come to that same conclusion with the use of a box plot. We just have to sort of imagine it rotated 9 degrees and set it on its side, right? But if it were vertically arranged, as our other box plots are, this lower tail is going to be on the left here, right? We can see this tail and some outliers out here on the edge is longer than this whisker or this tail on the right hand side, and we could say, hey, this data is negatively skewed, right? I have some non-symmetrical outliers. I have some lower outliers here that's going to skew my mean So maybe I'll want to use median when I'm describing it, perhaps, right? Or that might in some other way inform my analysis, right? The same way we can look at a box plot to identify negative skewness, we can do the same thing for positive skewness, right? Again, this right whisker or right tail is much longer than that on the left, right? Here, you'll see a histogram or a box plot in this shape fairly regularly, right? Where there is sort of right skewness, and that's because there's a solid lower bound of 0, right? So if I talked about like, maybe this is in portions of a second, and it's like reaction time to seeing a red light, right? No one can react to that event happening in a negative amount of time, right? Every value that we see is going to be 0 or larger. So I always think of that as this bell-shaped curve sort of smushed up against one of the axes, giving it a longer tail on the right-hand side, right? But either with the box plot or the histogram, right, with this lower bound at 0, we can identify some right skewness. And again, we can do the same to identify symmetry if both of the whiskers are approximately the same length. So that's about it for box plots. There is sort of a new sort of common variation of a box plot called a violin plot. And if we look at these, a lot of these, one, I think they're really pretty, but they can give us all of the information that you get out of a box plot in a histogram sort of in one place, right? In the center, right, I have this square, right? And this is maybe super small on what you guys can see. Let's see if I can't just make this a good bit bigger for everyone to see, right? We have this chart, right? And in our control, we have this sort of box plot, right? We have a tail, an upper tail, we have a lower tail, and we have this sort of box, right? And then we have this white line where the median is. So this really describes our data in the same way that a typical box plot would, but it also gives us the sort of curve, this lovely curve that represents our data in a similar way to a histogram with a lot of bins would, right? I think to achieve such a smooth curve, you'd actually have to apply some smoothing to that histogram. But you kind of get the general shape of the distribution, right? Like you would from a histogram, and the violin, and the information of the 5-number summary, sort of the min, the max, Q1, Q3, and the median that you would get out of a box plot as well. So sort of 2-for-1 combination with the violin plot. I also just think that they're very beautiful. Oh, this is maybe a better representation of it. I just think that they're really beautiful, right? I think in general, when you look at these plots, they display a lot of useful information, and they do so in a sort of elegant sort of way. It's easy to interpret, but it's also visually appealing, right? And I think that's really important when you're talking about data visualization. So that is it for box plots, which again, largely we're visually representing the 4 quartiles or the 5-number summary. And that's actually it for all of our plotting interpretation video series. We're going to move on in the next lesson. We're going to start talking about set theory. The set theory is really the basis of probability theory. Can't overemphasize the importance enough, but we'll leave that to the next unit. Really appreciate your time on this video. Make sure to hit like and subscribe if you're enjoying the course, and we look forward to seeing you over in the next one.